Why the hell did you know that?
This was my best friend.
Why the hell?
Alright, anyways. Are we okay?
He just does.
One more? Let's try one more, guys, okay? This will be the last one, I promise.
She doesn't like talking.
I promise. And then you can start on your assignment.
Nobody wants.
Yes.
Yes? Alright, so let's look at what they're giving us. What are they giving us?
F prime graph.
F prime. So is this the original graph?
No.
No, this is the what?
The list.
This is the derivative, right? So this is the list of the slopes. Alright, so let me label it. Okay, where do I have positive slopes at? Label that, positive slopes. Where do I have zero slopes? On the x-axis. Where do I have negative slopes? On the bottom. So when the graph of this function is up here, that means that the original graph is what? Increasing. When the graph is down here, it means that the original graph was decreasing because these are all negative slopes, right? Now what happens when it's equal to 0? Is it increasing or decreasing? No, neither, right? Okay, that's probably going to be where there is a what? A maximum or a minimum. So if on the questions below it asks you where does it have a relative max or min, okay, the only answers that you could possibly give are going to be what? 2 or -2. There's no other answers that you can pick. Okay, and they're all based on what's happening around it. Okay, we good? All right, so let's look at number 1 now that we have that information, and let's see if we can answer it. Okay, and remember, we always have to justify using what we're given, so we're given the derivative, okay? So when we write because, we have to write it because of the derivative, okay? So here we go. On what intervals is the graph of f of x increasing? So when is f of x increasing? So f of x is increasing when f prime of x is what? So in fancy terms we say what? Greater than 0. So looking at this graph, where is it greater than 0? Or let's say when f prime is greater than 0 or above, right? The x-axis, which occurs on what intervals? -3 to -2. Very good. That's where it's going to be increasing because that's where it's above the x-axis. That's where the slopes are what? Positive, right? So my curve has to be going up. That's the only way it could have positive slopes, is if it's going up. Good? What's the next one saying? Where is f of x decreasing? Very good. So f of x is decreasing when? F prime of x is less than 0 or below the x-axis, which occurs on what intervals? -2. We're underneath. We're still underneath. We're still underneath. Still underneath. Still underneath. Are we still underneath at 2?
No.
No. At 2 we are what?
0.
We're at 0. Okay, so I can't just say from -2 to 4, right? Okay, because at 2 we're not below 0, we are at 0. Okay, so you got to be careful. So we got to say on -2 to what? To 2 union 2 to 4. You have to split it at 2, okay? Because at 2 it's not less than 0, it's equal to 0. So we cannot include the 2. Got it? You with me, Cesar?
Yeah.
Okay.
Actually, yeah.
Let's look at number 3. Read it for us, Montserrat.
At what values of x does the graph of f of x have horizontal tangent? Just by your answer.
Okay, so we want the original graph to have a horizontal tangent. When does the original graph have a horizontal tangent?
And the slope of the tangent is equal to 0.
Very good. We know that this is true when the derivative is equal to 0. So let's write that down. F of x has a horizontal tangent when f prime of x equals to 0, which occurs at x equals 2 and negative 2. That was easy, right? So looking at our graph, when was the derivative equal to 0? 2 and negative 2. Okay? They didn't ask if it had a max or a min, they just asked when was the derivative equal to 0. Okay. Number 4. Now they're getting specific. When does the original function have a relative what? Maximum. How would I determine that using what I have? What goes from positive to negative? The slope, which is what? F of x or f prime of x? So f prime of x, right, changes from what? Positive to negative. So that means it goes from being where? Above to below the x-axis, right? And where does that occur?
I was like, oh, they changed it.
So when does it change from being above the x-axis to being below the x-axis? And what x value? At negative 2. Are we above here?
Yes.
Are we below?
Yes.
So it changed at what number?
Negative.
Negative 2. Only at negative 2? Below. Very good. Okay. Where do we have a relative what? Minimum. When does that happen?
2.
When it, what's it? When the derivative changes from what? Negative to positive. From being where? Below to being above. Where does that happen? It doesn't? So it never goes from being on the bottom to being on top? No, it just goes from being on the bottom to being at what? 0, and then still being in the bottom, right? So it never crosses over. So it never changes from decreasing to increasing the original function. Therefore, what? This does not occur. Therefore, f of x, the original function, what? Very good, Caitlin. Does not have a relative minimum. And if you want to be more specific, because it might have a relative minimum somewhere, but it doesn't have a relative minimum on this specific interval that we're working on, which is from negative 3 to 4. Okay, so if you want to be extra particular, throw in that particular interval. Because that's all we're looking at. We don't have any other information, right? I don't have anything beyond negative 3 or beyond 4. Good? Yes? Alright, the last 2 questions are the super easy ones. What is the slope of the tangent line of f of x at x equals 0? What's going to give me that? What gives me the slope of the tangent line? The derivative. Where at? 0. How can I figure that out? Look at the graph, right? Isn't this the list of the slopes? So what's the slope at 0? Negative 2. Oh, that's easy. What's the slope of the normal line at 4? How would I find that? Find the slope of the tangent line at 4, right? So what would that be, looking at your chart? -2, and then doing what? So the slope of the normal line is going to be what? 1/2 again. Didn't we use that one earlier? The opposite reciprocal. Pretty easy? You got this?
Got it.
We'll stop there. You want to keep going?
No, we're not there.
Want to keep going? Like, let's do the analytical point?
No.
We'll save it for tomorrow?
Tomorrow.
Okay. Yeah, you're going to want me to save it for tomorrow when you see your assignment. Okay? So, your assignment has a lot of problems on the graphical aspect of this, so it's very important that you understand it. Okay? Remember to justify your reasoning always using what you are given. Right? So sometimes you have to break down what you're given into what you're not given. Like, they give you the derivative, you have to think of the original function, right? Or, I mean, if you're given the original function, but they ask you questions about the derivative. So you have to work backwards, right? Break it down. What does this mean using what I have? What does that mean using what I have? And then use your graph to answer the question. Good? All right, on your assignment, I'm going to ask you to graph some derivatives. So we're going to practice that a little bit. We'll do a couple of them together. And then the rest will be your homework, okay? Will you pass these out, Montserrat? Pass them out for me while I turn off the camera.